Okie dokie. So we looked at solving equations with graphing, and we looked at solving equations with substitution. And the last method is solving using elimination, or sometimes you might hear the term addition. So what they mean by that is that if we add two things together and they're the same thing and one's positive and one's negative, you're adding the inverse and you are eliminating something. So just like if you had $5 in the bank and you spent $5, so a 5 plus a negative 5 would equal $0, right? So same method. So sometimes the equations are set up to be added, and then something can be eliminated. Sometimes it's not. So it just takes a little work. So this first one, a little out of order. Let's see what happens when we add two equations together and when it's set up for something to be eliminated, right? So I'm going to add this equation plus this equation, meaning I'm going to add my x's together, I'm going to add my y's together, and I'm going to add these numbers together. So again, no number in front of these x's, but I can put a 1 in front of both. So 1x plus 1x gets me 2x. Here I have a positive y and I have a negative y. So since one's positive, one's negative, if I add these two together, they get eliminated. And that's what I want. I add these two numbers together and I get 8. So here I have 2x equals 8. So I can solve for x. I get x equals 4. But just like everything else, you got to get a value for x, and then you got to go and get your value for y. So we're going to do what we did before. So now that we have a value for x, we're going to pick one of our equations and then substitute that 4 in to solve for y. And it doesn't matter which one, really, but I'd go for whatever you think is easiest. So if I do this one, so it says, oops, that's not what it says. It says x plus y equals 3. If I know x is 4, now I'm going to substitute that 4 in for x. I'm going to solve for y. So y equals -1. So my answer in coordinate form would be 4 for my x and -1 for my y. So it's not always set up that way. So you might have to manipulate it a little bit. Okay. Hopefully you can read my messy writing. So here we have this set of equations, right? If we added it as they are together, if I added this 1x to this -3x, nothing's going to cancel out. If I added 3 plus a -4, I'm still going to have a y. I'm still going to have -y. So that doesn't help me. So in this case, you want to look at your x's and y's and think, well, is there something I can do to change either the x or the y to make it to a inverse of the other? Okay. So this just takes some time to think about it. Hopefully it won't take you much time. But here, what would it take to change this 1 into a 3? Well, we just have to multiply this by 3, right? If I look at my y, can I multiply 3 by a number to make it into a 4? Now, and I can't multiply a 4 by a number to make it into a 3. So what you want to do is, if you have something where you can multiply just one line by something, that's kind of the easiest route. We could change these y's to get them to be the same, but that means we'd have to change both equations, both lines. So Rather than doing that, I'm going to take the path of least resistance, and I'm going to multiply this line by 3. Okay? And in doing so, when I multiply this through, I'm going to have a positive 3x here and a negative 3x here. And so these will be eliminated once I add them together, or I squish these two lines together. But I have to take this value and distribute it into everything. I can't just change part of an equation. I have to change the whole thing. This is going to be 3x plus 9y, and 3 times 18, 54. And again, don't forget about your signs. Okay, so we multiplied this 3 into this first line. When I put my second line underneath it, now I see that when I add these two together, these two will cancel out. And that's what you want. You want something to be eliminated. So kind of the easiest way to do that is to add the inverses. So you have to add a positive and a negative of the same thing to make them go away. So once we do this, we add these together. 9 plus negative 4, 5. And negative 54 plus a positive 14. So that's like you're down 54. And you come back 14. So if you owed someone $54 and you paid them $14, then you are only down $40. So now I'm going to solve for y. And negative 40 divided by 5 should be a negative 8. So I know what y is in this case. I don't know what x is. So I'm going to pick an equation and put this value in for y and solve it out. Again, not that this is a hard and fast rule, but what I always do is I always make sure I go back and I use if I have to use an equation that I manipulated, I go back and I use the original one. I'm not going to use this one. I'm going to use that one. Not that it makes a difference, but just what I tend to do. So that's what I'm going to do. All right, so the equation was x plus 3y equals negative 18. My y is negative 8. So when I multiply that together, that's 24. So x minus 24 equals negative 18. Solve for x, I'm going to add 24. Go down 18, come back 24. Just like that in the happy calculator. I get x equals 6. So my solution will be x is 6, and my y is negative 8. You're going to have two answers. All right. You're saying, boy, I hope the fun doesn't stop there. And you're in luck, it doesn't. So let's do one like this. Okay. So if we have this equation, or this set of equations, if we add them together as they are, if I add a 5 and 2, I get 7, so that doesn't go away. 4 plus negative 3, well, that's 1, so that doesn't go away. So this is a situation where I'm going to have to change something, okay? And when I look at this, well, unfortunately, nice and whole number wise. There's not a number I can multiply 2 by to make it into a 5, theoretically. Can't multiply 3 by a number to make it into a 4. So what that means is that I'm going to have to change both these lines, this line and this line, in order to get either the x or the y eliminated. And here's the thing, it doesn't matter which one you choose. Okay, I always try to do the path of least resistance, but again, doesn't matter. Some people are like, I want to get rid of the x's. Cool, get rid of the x's. Some people will look and say, well, would it be easier to get rid of the y's? Again, it's only up to you. I do say that what is easiest is that if you already have one's a plus and one's a minus, you already have opposite signs, then I would aim to get these the same, okay? Because sign-wise, it's already set up to, sorry, my cat is rubbing himself on my laptop. It's already set up to be added together to be eliminated. Working from home is awesome. So what does that mean? So that means I'm going to have to change this 4 and this 3 into the same number. So in order to do that, this is where you think of your multiples, right? Your bigger numbers. So if I take 4 and I multiply it by 2, that gets me 8. Not a bad number, but I can't change 3 into an 8. If I take 4 and multiply it by 3, I get 12. That's what I can change the 3 into as well. So it's harkening back to those old-timey times tables. Think about, as your numbers get bigger, what's the first one that they have in common? So this means I can change this value into a 12. Okay? So in order to do that, what do I have to multiply 4 by to make it a 12? Good, you have to multiply by 3. That means I have to multiply this whole line by 3. Don't forget about that back guy. That's usually what happens if we make a mistake. And then when we look at this line, what do I have to multiply 3 by to make it a 12? Right, you have to multiply it by 4. So I have to multiply this whole line by 4. Okay. So this will be distributed. And Cat is wanting to join the fun. So take that 3 and distribute it in. Then for this line, and take this 4 and multiply it in. I do not know what 27 times 4 is off the top of my head. So we did all that in order to make these two the same. So we made this value in front of y, one's a positive 12 and one's a negative 12. Okay. So when we add these two together, one's already a plus, one's already a minus, these will cancel out. We add 15 plus 8, is that 23? And 30 plus 108 is 138. I'm doing my math correctly. All right, so now we're going to take what's stuck to x, divide everything by that. So 138 divided by 23, we get 6. So 6 is a great value for x. But now we have to go back and find out what is the value for our y. So again, doesn't matter which one you pick. You can pick this one, you can pick that one. Makes no real difference as long as you do the math right. So I'm just going to pick this first equation. And so I'm going to substitute in 6 for this x. And get 30. All right. Subtract 30 from both sides. Divide both sides by 4. So we have y equals -5. So those are 2 answers. And just be careful that you enter them in the correct order. Because it sucks if you do all this great work and then accidentally enter it in backwards and then, you know, got an extra problem to do. Okay, so we did that one. And let's see. Do one more. And these are problems that I got right from the homework. So hopefully at least one of these might be a free answer for you. Okay, I'm going to do that a little later. Okay. So for this example, again, if we added these 2 equations together as they are, nothing's going to cancel out. 2 plus 3 will be 5. 9 plus 13 is 22. So nothing would be eliminated. Also, all the signs are the same, right? Positive, 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 positive. So positive x's, positive y's. And can't multiply a 2 by a number to turn it into a 3. Can't multiply 9 by a number to turn it into a 13. This means, again, I'm going to have to change both of these lines to make either my x coefficient the same or my y coefficient the same. Hopefully one's a plus, one's a minus. I'm not too skilled on the multiples of 13. I can get there, but, you know, again, path of least resistance. I know I can make a 2 and a 3 into a 6, right? So that's what I'm going to do. I'm going to change this, multiply this equation by a value to make this a 6x, and then this equation by a value, and to avoid subtraction issues, I'm going to make this into a -6. Okay. Before we had equations where one was a plus, one was a minus. Here, if we don't have that, kind of the easiest thing to do is go ahead and make one a positive and one a negative. Okay. So if I'm going to change this line in order to have this be a 6x, that means I have to multiply this whole line by 3. Again, don't forget about that fact. Okay. Here, for this second equation, 3x plus 13y equals -7. So if I multiply this by a 2 to make it into a 6, that's fine. But then I might have some subtraction issues rather than being able to just add opposites and cancel it out. So I'm going to multiply this by a -2. Right. So I'm going to distribute that. So I get 6x plus 27y equals -12. And then down here, I multiply this -2 in. So this is going to be -6x minus 23y. No, 26y, sorry. And then negative times negative is a positive. Okay. So I'm going to add these 2 lines together now. This 6x and this -6x will be eliminated. 27 plus -26, and it leaves a +1. -12 plus 14, that'll be a +2. If we have 1y, that's the same as 1 times y, or just y. So I already have my answer for y equals 2. So now that I know what y is, I have to go back to one of these equations and substitute in that value and solve for x. Again, you know, nothing wrong with this line, but this one seems a little bit easier to me. I'm going to substitute this value for y, which was 2, into here. And we get 2x plus 18 equals -4. Let's subtract 18. -22. And divide both sides by 2, so we get x equals -11. Okay. So again, it doesn't matter what variable you decide to eliminate first. But again, just I would hearken with the easiest one to do, right? To me, that seemed easier than dealing with a 13 and a 9. Okay. All right. So that is the end of that one. And I will see you soon.